Okay, so today's lesson is a slight variation on yesterday. It's still calculating probability using z-scores, but today what we're doing is looking at finding z-scores below a score. So when we mean below a score, it's very similar to yesterday. So we'll have a result that is above the mean. That's a z value that we have to find. And we can find this value from the table. But if you actually think about what we mean by below a score, is we actually need to include all this area as well. So this area from here to here, that represents half of the data. So the probability that it's in that is 0.5. So can you work out what the variation is on the last lesson, or what we have to do to our final answer so that it goes from being between the mean and the standard, and our z value, and being less than our standard, z value? That's right, you have to add 0.5. So the variation today is basically that you have to add 0.5 of. So if we take a look what an example would look like. So what we have, the reaction times of students is normally distributed. The mean, I should have the reaction mean of 0.3 and the standard deviation of 0.15. What is the probability the randomly selected students' reaction times will be less than 0.3375? So the steps, same as before. First thing we need to do is draw a picture. So we've got our graph again. So first thing is we put in the mean. In this case, 0.3. Standard deviation is equal to 0.15. The next thing is our z value. Sorry, our limit, which is 0.3375. So we want everything less than our limit. So that means everything mean and also continuing on. But this whole area here, we want to work out the size of x. So what does that mean for our z-score? That we know the mean is 0, we know the standard deviation 1, we don't know what 0.3375 is. So to do that, we need to calculate that z-score using the formula. Again, if you want, well, sorry, not if you want, if you could have a go at substituting those in and working to find the answer. So pause the video and then we'll have a chat about the answer. So pause now. So hopefully you had a go at answering that. So I'll just put the answers up now. So that gives us the answer 0.25. So then if we look at our step 3, look at the Z table to convert it. So 0.25, 0.25. So the one we're interested in is there. So probability is equal to 0.0987. So you might notice I'm drawing on the table. Because the table you get in the exam is a paper one that's you only use it for a certain number of questions, it is a good idea to write on it so that you're not likely to make a mistake. It's very easy to get the wrong line or the wrong row or column and make that clear. Just don't cover it up in case you need that number again. So now that I've got the probability, so now that we've got the probability, if we from the table, it means we've found that this area here in black, that is equal to 0.987. So for our final answer, that answer would be okay if we were asking what is the probability that it's between 0.3 and 0.3375. But because it's asking us what is the probability the time is less than that number, we have to include this area as well, which is 0. So in our final answer, the probability that x is less than 0.3375 is equal to 0.5 plus 0.0987. And of course, we need to write our final answer, needs to be written in context. Which you can see there, the probability that a student's reaction time is less than 0.3375 seconds is 0.5987. Sorry, I forgot to write that up here as well. So close to 60%. All right, so we've got another example here. So this time it's a shoe width of a horse. There's normally a distribution with a mean. The mean is 15.5 and the standard deviation is 2. What is the probability that a randomly selected horse width is less than 17.2? So again, make sure that you go through the steps. I want you to pause the video shortly and go through and work out your whole answer using all of the steps, and then see how you get on. So pause the video now and we can have a look at the answer. Okay, hopefully you gave that a go. So let's have a look what the answer should look like. So step 1 is draw the picture. The graph with our mean, the limit, which is 17.2, and the standard deviation. I'll now put in the z values. Now need to convert z into a 17.2 into a z value. So that moves us on to step 2, which is using the formula. So doing the calculating gives us 0.85 for our for the z. That means this must be 0.85. So now looking at the table, we get a probability of 0.3023, meaning that the area up the top here is the same as our probability. So the other thing we need to do is make sure that we add in this other half, which is 5. The probability that x is less than 17.2 is equal to 0.5 plus 0.3023, which equals 0.8. Um, 0.23. So then our final sentence. So the probability that a horse will have a shoe width less than 17.2 is 0.823. sorry, 0.8023. And that's it. So hopefully that's what you got your answer. Hopefully you remembered about the fourth step. Um, and it's pretty straightforward, just building on yesterday. So just recapping those steps again. So draw a picture, calculate the z-score, look up the probability in a z-table, and the last thing is write the probability in context. The only thing that's different today is that we had to remember to plus 0.5 when it's just being less than a score. Get onto your lesson page. There's another exercise. There's not actually that many questions in the workbook, so I've put a worksheet which you must complete as well.